it's me, Nate. So today's video is going to be on, it's a requested video, so it was requested in the comments. Basically, it was a spin-off of my gyro sensor turning that I posted 2 weeks ago. I got many comments on, okay, how do you turn both directions? Because the code I posted, you could only turn one direction with the PID loop. So I actually modified the code a little bit so then you can turn both directions now. And I will be going over that today. The other thing I want to mention just before we get started is that if you like the content I'm sharing on my channel, please consider subscribing. At 300 subscribers, we're going to be doing a giveaway. So if you want to be a part of that, please interact in my channels in some way. So comment, ask questions, things like that will get you an entry into that giveaway. Also, remember that last week I just want to apologize. I'm sure that you guys remember I didn't post. That was mainly because I was traveling due to work, and so I am back now, so I'll be posting like regularly, which is about twice a week. And some of the upcoming videos we have is how to win awards as a newer FLL team part 2. Another requested video, which is how to use the gyro sensor to drive straight, and then I'll also be posting another update on the Team I Coach's robot that we, it's kind of like an update on how we've been through the season. So those are the next 3 videos. So alright, with that said, let's get started. So it's very similar to here's the original code I posted like 2 weeks ago in my YouTube video. Let me see. Here it is. So I want to, just if you guys aren't familiar with this code, I would recommend going and watching that video first before you attempt to tackle both sides, because it's a little more complex. Also, if you watch my previous video on this, you can also, get a better understanding. So let's dive into both sides. So basically, it's pretty identical with the exception of a few changes. So I'll go over the blocks. So to be able to turn with the gyro sensor and PID loop on both directions, you want to start off by having a variable block here. Basically, what this right here is saying is it's taking your turn angle and then it's plugging it into different spots of your code. So let's say, we'll say in this example I want to turn 45 degrees. So it's going to put 45 degrees in this, 45 degrees in this, and then 45 degrees all the way over here in this section of the code right here. So just so you guys understand that, I will I'll move on. So basically, you want to drop your variable block, right? And you want to name it something. So in my case, I named it turn angle, which is the angle you're trying to turn. So then you want to change your variable block to a right block and numeric. That way you can, plug in your values, things like that. Or you can just type it up like 45 degrees. You can just type in this slot, that slot, and the last slot too, if it's easier for you guys. So the next thing you want to drop is this compare block. So the reason we have these compare blocks, we use 2 of them in this program, is because basically you have to distinguish in the code whether you want to turn left from right? So like if you want to turn left, you want to use, the turning left PID code. Now, if you're turning right, you want to use the turning right PID code. So you don't want to have, basically the problem I was running into was I would have, try to turn left in the PID loop, but then it would be using the right side's PID code or something like that. So you have to distinguish in the code so it knows when you type in, like, say, a negative angle to turn, that at that point you want to turn left. So if you type in a positive angle, turn right. If you type in a negative angle, turn left. So that's something basically we use these compare blocks for. So as you can see, we shifted the compare block to greater than and plugged in the value of 0. So what we're doing is we're saying, is this function or is this number that we typed in greater than 0? So, well, if we're using 45 degrees, then yes. So that means that, sorry about that, that means that, let me zoom out for you guys. If we are using anything greater than 0 degrees, we will use this section of the code. If we are using anything less than 0 degrees, so say negative 45 degrees, we will use this side of the code. Because this is a, this compare block, if I zoom in for you guys, 1 second. This one right here is a less than 0 degrees. So let's go back to the beginning so I can talk about the rest of this for you guys. So this is a less than 0 degree or greater than 0 degrees. Sorry about that. So you're plugging that into a switch, which is going to activate your PID turn. So the switch, you just go and click logic, and then you plug in the tags here, to your logic operation. And then basically, as for this side, I literally just copied and pasted that one code, that I talked about in my previous video, because as we distinguished, we know how to turn left. So if we, so I just literally copied and pasted this into the switch. If you, want to learn a little bit more in depth on how to code that, I would recommend, watching my previous video on that. That way you can save it and then just copy and paste it for yourself. Because I didn't want to waste any time for those who are really just trying to learn how to turn in the, towards the right direction. So, so we will skip that section. We're going to move on to the next, right after that. So basically, what you are doing is you're going to add another compare block after that, right? And you are going to compare, like I said, less than 0 degrees. So this is to turn that that direction, the opposite direction. So this is to turn the opposite direction. So you want anything less than 0 degrees, you're saying activate this side of the code. So basically, if you're saying turn negative 45 degrees, right? So if you're trying to turn negative 45 degrees, it will use this part of the code. So basically, essentially what you're doing is you are going to drop a switch down, same thing with the logic block, right? Drop a switch down with the logic operation and plug it into your compare. Then what you are going to do is add your gyro reset and a small delay, just so then you can, give it some time to reset. So now let's dive into the actual code. So what you're taking is you are going to measure or read your value that you are turning. So in this example, we would say negative 45 degrees, right? So we're going to read negative 45. To do this, you would just go into the read and the variable block, right? And then if you click the turn angle, it will read. If you click the turn angle, it will read that block. I have a previous video on variable blocks if you don't know how to use them. So you can go watch that if you need some reference. So basically, I have I'm reading negative 45 degrees here, and then I'm plugging it into a math block, which is then going to I've set to add function, and I'm adding 10. So what's that doing? I'm kind of setting up a threshold that I want to turn. So basically, I'm going to, let's say, negative 45 plus 10 equals negative 35. So I'm plugging that into a switch right here, which basically is going to activate two different functions. So one, it's going to activate my PID function to turn the negative angle direction, right? Though, when I say this PID function, it works really well, but when you're, say, in small increments, like, say, with, 5 degrees left or something like that, the PID function isn't tuned quite enough to where it would provide enough power into your motors to actually overcome ground friction, and it would not, your robot won't actually turn. So basically, that's what I have this bottom section for. So this bottom section is basically saying that if if at this point, you haven't, so it's saying if there's, the last 10 degrees turn at a constant rate of negative 4% power and 4% power. So that's what it's saying, is the last 10 degrees of your turn just at a constant rate, don't use a PID loop. So it's saying use the PID loop for the majority of the turn, and then just the last little bit, kind of just use a constant. So let's talk about that a little bit. So after the math block, you drop a switch down, right? So if you drop the switch down, you will then go into the gyro sensor and compare angle, and then you'll of course use this to set it to your port, etc. So you want to compare your angle as greater than, right? So at this point, you are taking 45 or negative 45. You're adding 10, so you have negative 35, and then you're plugging in the negative 35 value into your gyro sensor switch. So right here we have negative 35. So now what we are going to do for let's talk about these sections individually, the top and bottom. So the bottom section, you can just drop a constant and do -4 and 4% power on those motors, and that will just be your constant. So again, this section is just going to be the last 10 degrees of your turn to kind of overcome the ground friction, because the top section, the PID section up top, can't overcome ground friction in the last couple of degrees. So let's talk about this top section. Basically, you're going to start with a gyro measure angle. So you are going to measure the angle of your gyro. You are then going to plug that into a math block with the variable block. So let me talk about these two specifically, so then you can, because that sounds a little bit confusing what I just said. So basically, you are going to now, you're going to have the variable block again, where you read your angle, your turn angle. So in this case, we said it was -45 degrees. So you are going to then have a subtraction block here. So you're going to take, if you follow this wire, you are going to take -45 degrees. You are going to subtract whatever your gyro sensor is reading. See, subtract your gyro sensor, and the equal output is going to be then divided by 2. So let's see where we're going from here. So we're at -45 degrees, we are at -45 degrees here. We are then subtracting 0, so our output is going to be -45. Now we divide by 2, which is going to be -22.5, and then that's going to supply our drive motor. So we'll talk about that in a bit. Now, if, let's say, so at that point we're turning -22.5% power on our drives, right? So now let's say we're halfway through the turn, right? And let's roughly halfway. Let's say we've turned 20 degrees, right? So, this is mid-turn. We've turned 20 degrees. So at this point, you don't want to be turning, the crazy power that we were turning in the very beginning, because if you only have 25 degrees left, that's a small thing. You might shoot over your threshold if you're turning that fast. So let's say we've turned 20 degrees already and we're mid-turn. So this is going to take -45. It's going to then subtract 20 degrees and give you an output of 25. You're going to divide that by 2, and you can see that now we're only supplying our drive motors to 12.5, 12.5 power. So you can see how the power kind of decreases as you turn your robot. So that's kind of pretty cool. So hopefully you guys can visualize that a little bit better. If not, you can try the code out for yourself and you can see it on your robot and you'll understand it then. So at that point, what you're doing here, from here on, oops, sorry about that, grab the notes. From these two blocks, what you're doing is basically you're supplying your drive motors with the outputs, to turn. So one output, in this case, the -45 turn is going to have we said -45, yeah, it was going to have a 22.5, in one direction. So basically what you're doing is you're trying to get these drive blocks to have, to have inverse of each other. So they're trying to be, one's supposed to be positive, one's supposed to be negative, so you can turn. So that's why you take the output, right? And then which is negative, and then you would add it to one, drive. So you can see that if I follow this output, it's going into one of the drives. So it's going to be a negative value here. Now, to get the other one to be positive, what I do is I take the output, I multiply by -1. A negative with a negative will turn it positive, and then I plug that in the other output. So you have a negative output here and a positive output here. That'll provide your turn. So then, these last 3 blocks, what they do is this is, again, measuring your angle. And then it's going to add 1 to your angle and then equal the gyro sensor, which is going to interrupt the loop. So let me talk about this a little bit better. So you are going to, basically what this section is doing is, with our robot at least, probably with yours too, but with our robot at least, we would overshoot by 1 degree, right? So if we typed in 45 degrees, we would turn 46 degrees. We would always turn 46 degrees, and that was consistent. But we kind of, or sorry about that, if we typed in If we typed in 45 degrees, we would turn 46 degrees. So it was consistent that we would turn 46 degrees. So the idea was, how can we prevent, from turning, 46 degrees and make it so we're turning 45 degrees? So to do that, we, add 1. So let's, again, we're turning negative 45 degrees. So what would we want to do? We would want to add 1, so then it's negative 44 degrees, and then we plug that into the interrupt in the switch. That way the switch is saying stop at negative 44 degrees, and then with the 1 degree leniency, we'll actually stop at negative 45 degrees. So that works really consistently, and you can see if I go back to that other half of the program, right here we actually subtract, because this is with if it's a positive angle. So let's say let's say we're using positive 45 degrees to turn. Then it will subtract 1, give you a positive 44 degrees, and then it will, plug it into your interrupt the program. So it would stop at 44, and then the robot ultimately would stop at 45. So that's kind of how that works. So again, I hope I described this well enough for you guys to program this onto your own robot. If you have any questions, or any questions about the code, or any questions about any future videos, or anything in general for FLL, just comment in the section. I'll try my best to get back to you as fast as possible. And also remember that the key is that this part of the program does, turning one direction, say turn left, and then this part of the program makes the robot turn right. So you need to just distinguish those, and once you get that down, you should be able to follow the rest of the code pretty easily. Alright, I hope I helped you guys today. If you want to be a part of my giveaway, remember you need to interact in my videos, comment, ask questions, things like that, and I'll see you guys next time.